this is everything, but systematically. Fine. So this is what we have done. Blood group is the classical example of the multiple allelism. What we are talking about, usually gene exists in three alternative forms. Usually gene exists in three alternative forms. Usually gene exists in three alternative forms, right? And here what we have discussed, the classical example of the IS factor, right? IS factor is also controlled by gene. The blood group is positive if IS factor is dominant or expressible, that make a sense of positive blood group. And if IS factor is absent, that is because of the recessive nature of the allele, and this is what it's a. This is the classical example of the recessive blood group as a negative. Fine. Okay. Now, in the same continuation, here, there's a term like RH compatibility, right? RH compatibility. Here, male, female. There are four cases. Like if male is positive and female is positive, this blood group is compatible. Second case, if male is negative and female is negative, compatible blood group. This third is, if male is negative and the female blood group is positive, in the term of IS factor, this is compatible blood group. And the fourth is, if male is positive, if male has positive blood group, means if male has IS factor and the female does not. Female does not, in that case, this particular blood group where male is positive and the female is negative, this is incompatible blood group. Because in this particular case, the first child could be normal. First child could be normal. The first child could be normal. Okay. But second child onwards, there could be the chance of loss of embryo. Loss of embryo. Abortion. Right? And the cause of this abortion is blood loss. The cause of this abortion is the blood loss. And this is called as PRY PHRO PLASTO SIS FOETALIS. This condition is called as, see, erythroblastosis fetalis. This condition is called as erythroblastosis fetalis, right? So if male is positive and the female is negative, so in that case, the first child could be normal, but the second child onwards, there could be the chance of the loss of developing embryo because of the mismatch of the IS factor between mother and developing baby, mother and developing baby, and the result is the loss of embryo. This loss of embryo is because of the loss of blood. It's because of the blood loss, and this particular disease is called as the erythroblastosis fetalis, right? So this much of information is required for you. Apart from this, nothing is required. In the medical science, we also have medication for this particular condition, right? We also have a vaccination program to prevent this situation, right? This could be saved. This time we have medication to save, to handle this particular situation, but that is not required for the exam of UPSC. That's why we are not going to discuss. So this much of information is required for the UPSC exam that we have discussed, and they are going to ask only one aspect as a which blood group, which RH factor is the incompatible RH factor, and that is only when the male is positive and the female is negative, that leads to the incompatible RH factor between these two. That's it. Apart from this, nothing is required. And even if you're going to speak someone, if you're going to ask someone, I'm not going to ask, I'm not going to reply you on the screen because it is not required for exam to verify. Right? Can we go ahead? Can we go ahead? Can we go ahead? Yes, please. Allow me to continue. No, no, no. This is only in the case of, listen, it is always when the male blood group is positive and the female is negative. It is never in the case of negative male with the negative blood group and the female with the positive blood group. Right? Always one condition. Right? Always one condition is a unique condition. Okay, fine. Right. Okay. Even see here, negative RH factor. Negative RH factor. This can donate. This can donate. It's blood group too. This can donate blood to both negative and positive. But because there is no RH factor, negative is no RH factor. So this could be diffused anywhere. This could be diffused anywhere, right? But see, when we talk about the positive blood group, so this positive blood group, this can donate its blood only to the positive blood group. So the donor is positive. So acceptor must be positive. But if the donor is negative, so acceptor may be positive or negative. Because in the case of donor as a positive, yes, there's the RH factor. There's an IS factor. And if you are going to diffuse the blood with the negative, so in that case there could be the chance of, there could be the chance of agglutination because of the mismatch. Because of mismatch. So this could not be possible, only this is possible. But in the case of as a donor side, this could be possible for both A and B, because if the donor does not have IS factor, so that could be diffused anywhere, because it is not going to create complication to anyone. It is not going to create complication to anyone. Right? Okay. Done? Done? So, when we talk about the blood group, there are four blood groups. There are four blood groups. Blood group A, B, AB and O. Blood group A, B, AB and O. Fine. So I'm just mentioning here two statements. Statement number one: blood group is named after antigen. Blood group is named after antigen. This is the concept number one. Second is antigen and antibody. Antigen and antibody. Antigen and antibody.